I need shit. Check 1 2. Check, check, check. Parker, would you mind talking? Can you count off some numbers? Parker, would you mind talking? Can you count off some numbers? Talking Carls. I don't know if you were there for the video last year. Hey, Lily. Are you going to stay for class today? Is that the plan? I don't know if you caught yesterday. We talked about subtraction and whoa, phone interference. All right, do me a favor if you're gonna stay for a little while. Tell me how the mics sound. My voice echoey in the mics. I turned them down quite a bit, but it might be so much that the kids in class, when they talk, you won't really hear them. Although Parker was very quiet. He had a rough night. Got a lot on his mind. Hello, Connor and Blaze. The other person, so you did hear Connor, or did you hear Macy? Thanks, guys. Hear the announcements? Hey, Jocelyn. Hey, Grant. Okay, cool. Got Geraldine, Grant. Got everybody except I haven't seen Joe yet, and I haven't seen Brennan. All right, so a quick recap of what we did yesterday. We talked about subtraction in different ways to think about it. One of those ways, especially for the vets that were here last year, talked about subtraction as being way to find distance, right? Okay, gotcha. I think Mike, that's gonna pick me up the most. Probably this one. And these up. Okay. We'll try that. If it gets really bad, tell me. All right, so yeah, yesterday we talked about subtraction a little bit. We talked about distance. I know y'all were there the whole time and doing great, so I won't try to spend too much time reviewing it. Remember, one of the reasons that you might want to show up even when it's not your day to be here in person and stick around is it gives you something to write about in your portfolio, which is the end-all be-all for your grade. Very echoey when I talk. I only talk loudly. So, subtraction. If I have two numbers, Macy, give me a number. Okay, awesome. I'm not going to write that number down yet. Chase, give me a number. 7. Okay. So I waited to write those down so I could write the big number on the right, the small number on the left. To find the distance between those, if I were to ask you, you'd probably say 4 just because they're so small. But if you needed to know, you could do 7 minus 4 and figure it out, right? So the distance between here and here would be 4, because that is what 7 minus 3 is. I misspoke earlier. Right, and direction from 3 to 7 is this way. That means you move 4 steps to the right. Whereas if we took subtraction and did it the other way, we do 3 minus 7, meaning we start on 7 and move to 3. Again, kind of weird. The number we start on is actually the second number. And if we move this way, we would get -4, right? Same number, kind of hard to see that. Same number, but just different direction. In other words, different sign is what we're talking. So if I were to give you the problem 3 minus 7, you probably wouldn't be super sure about it, at least not as sure as when I asked you 7 minus 3. But it's the same problem. You can flip them, totally fine. You will get a different answer, right? We're not allowed to flip subtraction like we're allowed to do addition. But if you know what's going to happen, right? It's going to be distance, and the distance will be the same. It's just going to be the direction we head. You can remember, hey, I flipped the order of these to make it easier on my brain. I just need to remember to change the sign, right? Because all the sign is direction. Brennan's here. Awesome, awesome. Okay. And then Joe, I saw you. It looks like everybody's here except for Paul. Right. That's subtraction. We talked about this problem. And how would we solve a problem like Maria? We're going to play around with this one for a little bit, and then I'm going to switch over to stuff. Give me a way we could mess with this and solve this problem, 21 minus 7. People in chat, you're more than welcome to add in so we can move this along. I know this is a review for you guys because you're all here in person yesterday. Hopefully it's a review for you guys, but if it's not, that's okay. That's why we're here. 21 minus 7, how would you do it? Plenty of different ways. You can even give me the boring way if you want. What would you do? Use your fingers? Okay. So using your fingers, what would you do? Explain that to me. And then Lily, I'll get to your idea. Ooh. So you would do 20 minus 7? And then add 1 later. Oh, that's really clever. That's really, no, it is, seriously. That's much easier. I can do that every day. 13, because, right, it's a multiple of 10, right? 7 and 3 go together, so it's got to be 13. And then I just add 1 back later. You can totally do that, right? Because 21 is just the same thing as 20 plus 1. It doesn't matter what order we do it in for addition. And really, it doesn't matter what order we do it for subtraction, really. As long as we're careful. So I can write it like this, and it'll be the same answer. I can write it like this, and it will be the same answer. I can write it like this, and we'll get the same answer. But yet, you know from past experience, you're not allowed to just do subtraction in any order you want, right? It screws stuff up. I mean, look at this, right? 3 minus 7 is not the same thing as 7 minus 3. How are we allowed to do subtraction in any order? Well, it's when we think of it as addition. So all these guys right here, what's going on is we have 20 plus a -7 plus a 1. We've got 20 plus 1 plus a -7. Do you see I'm thinking of that minus as a plus? I'm adding a -7. Really what's happening here, you don't have to write this. This is kind of gross looking, right? Really what I'm doing is that the sign is with the -7, right? The minus is with the 7. And so whenever I move it, I just make sure that the minus stays with it. That's all. That's all. As long as I do that and the signs stay with the numbers, right? 20 is positive, so when I write it here, it's going to be a plus. 1 was positive, so when I write it here, it's going to be right? You can do whatever order you want. The reason it didn't work the same up here is because, look, the minus sign's with the 3. What's the minus sign with here? The 7, right? 7. So as long as you keep the signs, oh, hey, Paul. As long as you keep the signs, I need to get that, you know the Jimmy Neutron ending? The monkey with the 3 eyes? Hi, I'm Paul. I need to edit that. Write that down. This entire class this year will be a Jimmy Neutron reference, I think. Got a blast! Got it. Got it. Okay. You guys see the Jimmy Neutron movie in theaters? No, you didn't, because I was like 7 when that happened. But there was a movie. It was amazing. You know how when you go back and watch the first Shrek, and you're like, wait a minute, why is there no background? Why does this look so crappy? And you didn't realize when you first watched it how bad the animation was, because we've come so far. That is Jimmy Neutron. All right, so keep the sign with the numbers, and you can move it around, actually. But subtraction is associative as long as you think of it as addition, which makes sense, right? Because addition's associative. You can move it in any order you want. And commutative. You just got to keep the signs with the numbers. Okay. Give me another way. Lily talked about 21 minus 7. She knows it has to be 14 because she thinks of 21 minus 7 is really, the way she thinks of this is 3 times 7 minus 1 times 7. I'd use parentheses for organization. You don't actually need those, right? If you want to do PEMDAS, which I think is a waste of everybody's time, if you have to bust out PEMDAS, it's because the person didn't write their stuff very clearly, right? You know, Chinese 5th grader can figure this out, right? Can you? 3 times 7, that's multiplication. That comes first in PEMDAS, and then subtraction's like last, right? That's the S in PEMDAS. So we would never do 7 minus 1 first. So you don't need the parentheses. But I think it's better for organization. 21 minus 7 is what's going on over here. Same question, right? Just a different way of looking at it. 3 groups of 7 minus 1 groups of 7. How many groups of 7 is that going to be? 2 groups, right? Which, of course, we know is 14. Could you have just jumped to the chase? Sure, but I'm showing you the logic, right? 3 groups minus 1 group is 2 groups. And because we're talking about apples here, and not apples and oranges, right? They're both 7s. We can do that. Totally fine. Totally fine. Give me another way to think about 21 minus 7. People in chat, feel free to participate. I might have to get to your suggestion kind of like I did Lily's a little bit later, but I will do it. Give me another way we can do this. You can give me the boring way if you want to do that. You can. Something about borrow and carry across sounds painful. Not particularly pleasant, but we can do it. Come on. We talked about we can make subtraction commutative and associative, move stuff around as long as we think about, instead of subtracting them, we add them. Right? What else you got for me? Like that? Yeah. Add the 7 to 21 and then divide by 2. Interesting. So what's going on there? Because it works, right? The question is that a coincidence or is there a reason behind it? So we add the 7 to 21, and then we're dividing by 2. It just happens to work. Did you have something to add to this, Parker? Sure. So we're talking about like 3 times 7 here, plus 1 times 7, and then we're dividing by 2. So we have 4 groups of 7 divided by 2, which gets us 2 groups of 7. I don't know. Right now I'm thinking that might be more coincidence. Right? If I'd given you a different problem, even if they were divisible together, I don't think dividing by 2 would always work. So like imagine I had 28 minus 7. Right? I'd have 4 times 7 plus 1 times 7, 5 times 7. Dividing by 2 just seems to magically work, you know what I mean? 4 and 2. Right. That's what's going on here. Something times 4, then divided by 2. You might as well just times it by 2, right? Not a bad thought. Alright. Let's cut to the chase. Back in school, wouldn't you do something like this? 1 minus 7. Oh, can't do it! So what do? Yeah, we turn that into a 10 or something. And the way we do it is we cross this out and make it a 1, and then borrow another 1 from here. Now, question. What did that 2 stand for initially? What does that 2 stand for? Think place value. Doesn't stand for 2, right? That 1 stands for a 1. This 7 stands for a 7. What does that 2 stand for? Oh, come on. Yeah, it's 20, right? So when we borrowed a 1, we didn't really borrow a 1, we borrowed a 10, like she was saying, right? And so now we have 10 plus 1, because this one right here stands for a 10. That's another one, that's 11, right? That's where we get the 11 from. So what's happening here is we're thinking this is 1, or a 10, sorry, 10 plus 10 plus 1, and we're subtracting 7. That's really what's going on here. 10 plus 10 plus 1, or 10 plus 11, whatever you want to do, right? And then we have to do 11 minus 7. How are we going to do that? No idea? Well, you had a brilliant method earlier for 21 minus 7, right? Yeah, your fingers. So 10 minus 7, and then add 1 back, right? That's 3 plus 1, which is 4. Okay. And then what do we have to do next? Because that's not the answer. What do we got to do next? How long you guys been doing subtraction? Since you were like, I don't know, 6, right? Bring the 1 down. What does it mean? Why do we bring the 1 down? It's true, we do. Oh, yeah. So what's happening is we have a 10 minus nothing, right? We already subtracted 7, so now we don't need to subtract anything more. So another way to think of that is this, right? Whoops, sorry, let's do it down here. So we have to subtract 7. That's great. And then over here, we're not subtracting anymore. We're done. I don't know. This seems kind of ridiculous. But we don't need to subtract anymore. So whatever's left over, this 10, right? We took this and made it 3. And then we added 1 to that and got 4. What's left over, the 10, right? We bring it down more or less because there's nothing more to do with it, right? So it's 10 plus 4, which is 14. Okay, cool. What if I told you didn't have to borrow? What if I told you the world was yours? You don't have to borrow and carry across. Remember, subtraction is distance. So when I ask this question, what's 1 minus 7, I'm really asking, remember the second number is where we start. If I'm on 7 and I move to 1, how far did I move? What's the distance between 7 and 1? 6, right? But it's minus 6 because we're starting on 7. We're going backwards to 1, right? Exactly, right. So you could think of this as just 1 minus 7 and just know that's negative 6. That's fine, right? The reason the way I reassure myself is I think, okay, subtraction is distance. Distance between 1 and 7 is 6. The question is, which way are we going, right? It's always the second number that we start on. It's kind of weird. 7 going to 1, it's minus 6, right? Or 1 minus 7 is fine, right? 1 minus 1 is 0. Minus 6 more is a negative 6. I don't know. And then we have nothing here, right? So 20, that's what that 2 stands for, yeah? What's 20 minus 0? 20. Whoa. You don't have to borrow. You just do math. Why did we borrow? Well, 1, because that's the only way your teacher knows how to do this problem, probably. And 2, because you didn't know what negative numbers were when they taught you. It's just negative 6 plus 20. Or 20 minus 6. Or you could do it 20 minus 7 is 13, and then we have 1, which we don't do anything with, right? 20 minus 7 is what we did. Whoops. Minus 7 plus the 1 left over, right? Macy's method. Which she thought was dumb, which is actually brilliant. Every day I find a kid that thinks they have a dumb idea, or that they're dumb because they don't have any ideas. And it turns out the reason you don't have any ideas is because you've never been asked to have any ideas. How do people come up with this? The way they come up with it is just what Macy did. The thing we don't have time to ever do in school. The thing we don't do inside the classroom. What's the one thing we never do in the classroom? Think. That's how we come up with stuff like this. So you're telling me 21 minus 7 is the same as 20 minus 6? What do you notice about those numbers? Let me zoom in. What do you notice about them numbers? Except, I mean, they end up being the same thing. Yeah, it's true. Are you saying the numbers individually the same thing, or just they're both the answers the same? Yep. We covered that. But that's good. That's true. The question is why, yeah. Do you see how this is 21 and 7, and this is 20 and 6? Subtraction is distance. And you're like, who cares? Okay, great. Think about it. Here's two numbers on a number line. I'm not going to tell you which ones they are, okay? Now imagine I add 1 to both those numbers. What happens? Did the distance change? And if the distance doesn't change, that means subtraction is the same, right? 21 and 7 on a number line. I'm going to go to 20 and 6. That's subtracting 1 on both, right? Did the distance change? No. So 21 minus 7, hard problem potentially, but 20 minus 6 is easy. We call that shifting. $54 minus 27, how can we shift that? What must that be equal to that might be easier to do? No yawning, math class. 21 minus 7 equals 20 minus 6. I can do 20 minus 6 much easier, right? 54 minus 27. How could I shift this around where I don't change the distance between the numbers because I add the same to both or subtract the same to both, right? So I get the same answer, but it's easier on my head. What kind of numbers are easiest to work with? Yeah. Say it again. Little numbers, that's true. Getting these to be small, though, might be difficult, right? That's subtracting a lot, and that might be harder to do than the problem itself, right? What other numbers are easy to work with? You're not. What would be an easier problem than this? 54 minus 27. What do you wish that 54 was? Yeah. Parker? Oh, looking at your hand. 34 minus 7, how'd you get that? It's a little bit easier. You see how these are 20 apart? Again, as long as we shift them both the same amount, the distance shouldn't change. So the problem's the same. 34 minus 7 might be easier. I don't know. What if we made that into 30 minus 3? See how they're 4 apart? Ah, okay. That's 27, obviously. Right? Much easier problem. I can do you one better, though. What if we did 54 minus 27 and we rethought of it as 50 minus 23? What's 50 minus 25? 25.
25.
So what must be 50 minus 23? Yeah, 27, right? 50 minus 25 is 25. So if we subtract 2 less, right, we don't take 2 more away, well, then we'll have 27. Try another one. Are you doing groups? Yeah, they happen to be divisible. We're going to talk about divisibility tomorrow. Or next week. Give me a number, Parker. 73. Carolyn, number. 56. I'm going to subtract these bad boys. How do you want to do it? You guys not want to utilize your freedom and autonomy yet? I know it's going to be a big adjustment to get used to non-authoritarianism in here. The teacher told us how to do it. And we do it again and again and again until we get good at it. Some of us don't. And that's education. Well, we can do it the boring way, right? Borrow. We're going to have to borrow, right? That becomes a 6. That's a 13. 13 minus 6. So I got to think of that now, right? This is easier, right? Okay, let's pretend we did that. Let's say we did. What's 3 minus 6? It's gonna be negative, right? What is it? Negative 3. Remember, you can do 6 minus 3 or 3 minus 6. Doesn't matter. Just remember that if you do 6 minus 3, you're switching the order, so switch the sign. 6 minus 3 is 3. But we wanted 3 minus 6, so it's negative 3. What's 7 minus 5? Yep, 70 minus 50 is 20, right? Gotta make sure you know those are 20s. 17. How do you like that method? 70 minus 50 is 20. 3 minus 6 is negative 3. 17. Yeah. You count it up, huh? That's another way to do it. Check it out. If we start on 56 and count up to 73, that's going to get us the answer. But why? Well, here's 56, here's 73. What you're doing is counting up like this. You're saying, look, I know from here to here, 1, 2, 3, 4, that's 60, and I counted up to there because 60 is nice, right? Multiples of 10s are nice to work with. And then I need 10 more to get to 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 70. And then 1, 2, 3 more to get to 73. So I had 3 here, 10 there, and 4 here, right? That's 17, counting up. That's not too bad. When the numbers are close together, counting up doesn't suck too much, right? Really, all subtraction is counting down, right? 73, 56, what's the distance between them, right? Same way. Oh, I'm sorry. Thank you very much. Okay. What about the shifting thing? You want to try that? What can we make this to make it easier? You want to shift 73 up or down, or you want to shift 56 up or down? What do you want to do? Not sure? One way might be this. Let's add 4 to both of these. What's the answer to that? Yeah, 17, right? Pretty clearly, right? You can count up, count down, whatever you want to do. You can see, oh, it's 10 plus 7 to get there, right? 17. And the reason this works is because, again, 73 and 56 are this far apart. 60 and 77 are the same distance apart, right? Because all we did is shift them both over. What's another way we could shift? Maybe we could shift down. I don't know. Maybe you prefer that, maybe you don't. Maybe you like this better. I usually like having the second number be a multiple of 10. Makes it a bit easier. That's 17, right? 7 more to get to 60, 10 more to get to 70. Yeah. You like the 3? Yeah. You like 3 better than 7. That's interesting. And again, we can do subtraction in any order, as long as we keep the signs together. So another way we could do it is this. Let's zoom out a little bit. Use thicker markers. So we can think of it like this. 73 minus 56 is really just the same thing as 70 plus 3 minus 50 minus 6. Again, we're keeping the signs together, right? That 50 and 6 are minus. It's not negative 50 plus 6, because that's going to get us a different number, right? It's negative 50 and then subtract 6 again, right? If I want to take money from you, I can take 50 and then 6 later. Or I can just take 56 all at once, right? Well, I can do that. That's 20. Plus 3 minus 6. I don't know. If you don't feel comfortable right away, you could think of it like this. That's gone. 17. Or you could just do 3 minus 6, get negative 3, 20, 17. Lots of ways to do it. And if you can explain why it works, again, the distance thing of shifting, right? It doesn't change the distance. Subtraction is obviously distance, right? Switching the numbers around, making it 56 minus 73, and then changing the sign. I don't know. That would probably not be a good one for this. At least making it easier on you. Lots of ways to do subtraction here. What I want you to do, and this includes the people at home, I want you to write a post. You have to do this. If you've already done one, great. If you haven't, You need to. I need you to write about a post about addition, subtraction, or multiplication, and write about different ways you'd solve a problem. Pick a problem like 73 minus 56, or I don't know, 21 minus 7. And explain all the different ways you can do it, as many as you can. And explain why it works, not just how to do it. Okay, you borrow the 1. Are we really borrowing a 1? No, we're borrowing a 10, right? Why does this work? Right? Well, it's because we're thinking of it as 10 plus 10 plus 1. And I can do 10 plus 1 minus 7. That works. 4, 10 minus nothing, 10, add them together, 14. So choose subtraction, multiplication, or addition. It's up to you. If you want, go back on YouTube, previous classes that we've had, and go back and watch the video. Fast forward through it, pause it, or whatever. The videos are labeled. Today's video is called, let's see. It's labeled by date as well. Today's video is called 9, 18, 20. Playing with subtraction and maybe division. We didn't really have time for that, I don't think. We'll hit division next week. Then we'll hit fractions. Fractions, hate them, right? Why do you hate fractions? Let's talk about that. Right, yeah, so even fractions that are nice, like they're nice fractions. There are some fractions you hate more than others, right? Gotcha. Not comfortable with those. And adding and subtracting, you need common denominators, and that can be a pain, right? You know why you need common denominators? Yeah, we're going to talk about that. It actually makes a lot of sense. In fact, division is just multiplication. And I know you kind of know that. They're like two sides of the coin, but they work the same way. So for instance, you know that 4 times 7 plus 8 times 7 is going to be the same thing as 12 times 7, right? Has to be. 4 group of 7, 8 group of 7, right? Well, check this out. 100 divided by 4 plus, and again, I can group them like this just so you're comfortable, right? 100 divided by 4 plus 100 divided by 5 is just 100 divided by what? Let's check it. 25.
25.
20. We get 45. Oop. See you guys later. No spoilers. Hey, Campbell. Kobe. Backboard. See you later. Go write that post. People that have not met with me or don't have a syllabus yet, I can get you a syllabus right now. If you haven't met with me for portfolios.
I don't have a syllabus.
Gotcha. Let me help you out. Keep forgetting on this day. Y'all need syllabus? Yes, no. Maybe there's a part where your parent can sign it. Might have given you two there. Talks about how we do portfolios. I think from now on, portfolio conferences will be every other week, A, B, day, Friday. I like your nails. That'll give us more time to do them. Hello, everyone. I need to spray down the desks. I will be with you momentarily. Time to spray them down. What's up? Hi.
Hi.
Am I the only teacher that sprays down the desks? Okay, good. You think so, Jace? Maybe you just get there late. Good for Miss Palmer. I don't know her very well, but we both joined. Hello, Sarah. Hey, Olivia. All right, so I'm seeing Campbell, Annie, Blake, Marissa, Olivia, Sarah, and Mika. Yo. I don't know when works for you.
Yeah, I know. I didn't.
Also, there's that up on the board. Oh, sure. Thank you very much. All the freshmen turning them in. Like good kids. Everybody else, no, trust me, you're fine. It's not necessary. I prefer it, but it's not necessary. Did I see Corinne? I don't see Corinne. Theron, didn't see Theron yet. Didn't see Shion yet. I saw Annie. I saw Marissa. Did I see Katie? No Katie yet. No Lauralee yet. No. Yeah. Okay, Katie's here. Oh, thanks, man. All right, so announcement on the board that you guys can't read at home. And we will have a sort of an assignment today. It's really just more like a, hey, I want you to write about this. And you get to pick, but make sure you stick around if you didn't yesterday. Did you get a syllabus, first of all? Everybody in here get one? You must have. You turned them in. And then also portfolio makeups today from 105 to 325. We're not going to be making a habit of these portfolio makeups. It's not happening. You'll have to wait till the next portfolio thing. Okay? That's fine. Hey, Shion. Hey, Corinne. Hey, Jaden. So, yeah, we're not going to make a habit of doing portfolio makeups. That's just not going to be a thing. Like devoting like 3 hours of my time to doing that on a day when I already, or the day, a couple days after I already devoted 8 hours of my time. We're not going to be doing that. So make sure you're showing up for those appointments. Again, you have Tuesday, Thursday, and Wednesday to do those when we do them. In the future, I think what we're going to do is have portfolio stuff like that be every other week. So 8A kids, B kids. Time to talk. Talking about portfolio. I had to rush through them. They were 5 minutes each, and I didn't want to be late for my next meeting. And I think that is just not as good. I'd rather have more time. All right, cool. Looks like everybody's here except Mr. McCartney. All right, so quick recap of yesterday. We learned about subtraction, and subtraction is what? What is subtraction? Subtraction is what? It's subtraction. What else is it? Tell me something I don't know. Yo. It's difference. Yeah, that's another way to think of it. Yep. The difference between two numbers. There's another word that's very similar to difference that actually it fits with as well, right? Think on a number line. If I'm on 5 and you're on 7, the difference between them is really what? Another concept. Going this way, right? They're separated by 2. When we say separated by something, what are we talking about? Like between here and Fulton, what do we talk about? Distance, right? Subtraction is distance. It's difference too, right? Sign up for the makeups. There is no sign up. I just have the time between 1:05 and 3:25 today. Send me an email and we'll figure it out.
Looks like I won't be.
Nope, but not most of you. Most of you guys, like I think like 3/4, maybe more than that, already did them. There are only a few that need to get in, but it'll seem like a lot because I have 69 kids, and a quarter of those, right, is about 25. So probably about like, I don't know, 12 of you. But if we go backwards, we get -2, right? Because subtraction or minus signs like this, negatives, only just mean direction, right? The direction we're heading in. This is 7 minus 5. Notice that the second number is where we started. That's kind of weird, right? 7 minus 5 is 2. The distance between 5 and 7 is how we'd read that. This would be the difference between 7 and 5. Again, second number is where we start. Thank you, Katie. And yeah, so if you get a problem like 5 minus 7, if you know that the only difference that we're going to have here between the two answers, these two versions, is direction, right? Because that's all it is. You can flip that around if you want. 7 minus 5, get that answer, and then change the sign. 7 minus 5 is 2, way easier question. But it's -2 because we're heading from 7 to 5. That's it. That's all negative numbers are, man. They're direction. Which way you're heading. We talked about that yesterday, and distance is subtraction. That allowed us to do this. So we had a problem 21 minus 7. We had lots of different ways of doing it. I'll catch y'all up. So 21 minus 7, the regular way of doing it. What would you do regularly? People online, you're more than welcome to tell us, right? The borrow and carry method. Borrow and carry across sounds painful. What would you do? How would you solve a problem like Maria? Come on, give me a method. Any method. People on the stream, your assignment is to pick either multiplication, addition, or subtraction and write a post about all the different ways you can do a problem. Make your own problem up, right? And explain why it works. Like, for instance, if you were to do this method, well, can't do 1 minus 7, so I got to borrow a 1 from over here. Explain why that works. Well, what were you going to say, Jace? Say it again. Sure, yeah, it's going to start with a 1, right? The answer. It's going to be in the teens. Sure. So I think what's going on here is we're rethinking of 21 as 10 plus 10 plus 1. That's a 10, right? The 2 before was a 20. And we're borrowing a 10. We're separating it out into 10 and 10 and 1. Well, 10 and 1 is 11. I can do 11 minus 7. It might be easier to do 10 minus 7 and then add the 1 later, right? Do something like this. There's the problem, and say that's 3. And now you get your answer. But anyway, that's why this method works. 11 minus 7. How would we do that in our heads? How would you do 11 minus 7? And Lily's right. We can break this down multiples of 7 because they're both divisible. But we'll talk about that soon. We haven't talked about division in here. How would you do 11 minus 7 in your head? To do it? How do you be sure of your answer? How could you convince a third grader that 11 minus 7 is 4? How long have you guys been doing subtraction? A really long time, yet you don't know how to do any of this stuff. Isn't that shocking? I don't blame you necessarily. 11 minus 7 is 4. We know that because one way, 10 minus 7 is 3, right? So 11 minus 7 must be 4, just following logic, right? If 10 minus 7 is 3, 11 minus 7 must be 4, 12 minus 7 must be 5, etc., 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 right? Farron is doing 10 minus 7 plus 1, which is what I just said. 10 minus 7 is 3, and then add 1 more to make it 11, right? We can add in any order. That's fine. And then we have a 10, that's what that 1 means, minus nothing, which is this, right? We bring down the 1, and that's why, because it's 10 plus the 4 that was left over, right? And so we get 14. Oh, hi. Now, I said earlier that we can add in any order. Can we subtract in any order and get the same answer? You might think no, right? Because look, I switched the order and did I get the same answer? No. Very similar, though. You can always correct at the end. But I'm going to show you something. Isn't that the same as 21 minus 7? It is, right? Because again, you can add in any order and then we can subtract. What about this? What about this? 1 minus 7, negative 6, yeah? Negative 6 plus 20? 14. Wait, what? 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 You can't, but you can? No, you're not in math class! So, oh, it's a joke, okay? Girl, you can fall asleep in here if you want. So, what's happening? Well, it turns out you can subtract in any order you want as long as you think of it as addition. Wait, what? That's what I'm doing. Right? I'm adding it. And that's really confusing looking and looks really awful and not very fun. But that's what's happening. In other words, what am I doing? See how when I wrap it in parentheses, I'm keeping the sign with the number, always? You don't have to wrap it in parentheses to do that. See how I kept the sign with the 7? The 7 was negative, right? Well, I just kept it with there. See how up here the sign changes places? It's with the 5 and now it's with the 7? That's the difference. Go. That's the difference. As long as you keep the signs together, you're fine. You can do it in any order you want. PEMDAS is a lie. You have to know what it means. Just keep the sign with the 7 and you're fine. You can do them in any order. And I'd argue something like this is a bit easier than this. 20 minus 7, 13. In my sleep. Plus 1, 14. Great. Awesome. Another way. Because remember, subtraction is distance, right? 20 minus 7 is the same thing. Whoops, sorry. That's not the original problem, is it? It's the same thing as 20 minus 6. Is that a coincidence? Do you see the connection between these numbers? What's the connection between 21 and 7 and 20 and 6? Or 21 and 20, 7 and 6. What's the connection? One number lower for both, right? Subtraction is what? Distance. Imagine two numbers on a number line. They're separated by this amount, right? Now imagine I take those numbers and shift them both over 1. Did the distance change? No. What if I take two numbers and I add 5 to both of them, shifting them over to 5? Did the distance change? We can do anything we want as long as we understand what's going on. It's not adding to both sides. It's not PEMDAS. It's logic. I can't do that with addition, right? Imagine 4 and 6 on the number line, and I add 2 to both of them, right? Now we have 6 plus 8. Is 6 plus 8 the same thing as 4 plus 6? No. Because addition isn't distance. The distance doesn't change. This is an easier problem, isn't it? Let's take a different problem. People that have been hanging out and waiting for a new problem, here you go. 73 minus 56. Let's shift those around to nicer numbers. Remember, if you shift one number to a nice number, you have to shift the other by the same amount, right? Otherwise, the distance would change, right? Imagine Patrick pushing Bikini Bottom. Take Bikini Bottom and push it over there, right? It changes the distance. But if you push Bikini Bottom and Rock Bottom the same amount, the distance doesn't change. Isn't that beautiful? So, which one would you like to shift and where? Let's change the problem. Something that's going to end up being the same. What are nice numbers to work with? What kind of numbers are nice to work with? Tens, right? How can I make that into a multiple of 10? There we go. Words are hard. Add 4, okay. So if we added 4 to this one, what do you have to do to this one? And the distance should stay the same, right? We moved them both over 4. What's 77 minus 60? You don't even have to think about it, do you? What? How long have you been doing subtraction? How long have you been doing subtraction and they haven't told you this? In all the years that you were doing it, they didn't think to bring this up once? Like, hey kids, fun day, right? I know the rest of the time we're going to do this. Okay, class, 10 minus 1, what is it? 9. 10 minus 2, 8. 10 minus 3, 7, right? Okay, tomorrow we're going to do the same thing, but we're going to start at 20. This is education. Some of you will get it, some of you won't, and the ones that get it will get ice cream, and the ones that don't will get Fs. Give me a number. 50 and 6. Ooh, so Sarah's saying, what if I do this? Now notice the sign has to stay with the number, right? It's not minus 50 and then add 6. Right, imagine you have a bunch of money and I want to take $56 from you. Of course I do. I could either take 56 all at once or I could take 50 and then 6, right? I wouldn't take 50 and then give you 6. So they're both minus. But this is easy because now I've got 23 minus 6, which is just 23 minus 3 minus 3, which is just 17, obviously. Again, I want you to write about subtraction and why it works the way it does and the different things you can do with it. Subtraction is not commutative. It's not associative. You can't do subtraction in any order. 7 minus 3 is not the same thing as 3 minus 7. However, 7 minus 3 is the same thing as negative 3 plus 7. just have to keep the signs with the number. If the 3 is minus, it's always minus. Subtraction is distance. You can shift them around. Jace, give me a number. 54. Okay, 54. I'm not going to write it down yet. Haley, give me a number. 32. Now remember, the distance between 32 and 54 is the same as the distance between 54 and 32. It's just the direction's different, right? Is this answer is going to be negative, right? So, boop, it's negative. Great. What's 54 minus 32? Maybe that's an easier question in your head. Think about it, flip it, do the subtraction. What is it? 22. Done. Are you kidding me? Do you remember 6th grade and when they introduced negative numbers? Oh my God! Messing it up all the time. 3 minus 7. Oh, it's 4. Nope, sorry, it's negative 4. Damn it, I guessed wrong. Why? Johnny, is it going to be negative or positive? Oh, obviously negative. Great. Now what's the answer? Negative 4. They couldn't have told you this once? What's another way to do this? You want to shift? What would you shift it to? So 30 minus, and then we got to shift this to 52. Flip it in your head and then negate it, right? Whoops, sorry. Yeah, did I do that right? 22? Yep. 32, 22, 22. Yep, we're good. Sorry, numbers are hard. What if we shifted the other way? So we shifted this to 30. What could we shift this to? 50? Okay, so we're shifting down. Minus 4. Ooh, how do we do 32 minus 4? Minus 2 minus 2? 28, right? 50 minus 28.